Hi, the viewers of NTV. I'm very happy to welcome you all to this today's session of My Teacher, the biggest classroom of UAE. As you've been seeing the sessions in the days gone, today we are with one of the contents which you're going to have for the 10th standard physics. So I request the 10th standard students, if you're watching the program, listen to the session carefully, make use of the session as effective as possible. And if you're not at home, if your parents watch this show, it would be better for you to record this or you can watch it tomorrow morning as well at 7 o'clock. And meantime, you are able to ask your confusions or doubts over the telephone, or you can SMS your queries to us. You can see the number displayed on the screen. You are aware that 10th standard examinations are coming up. It's very fast approaching. 1st of March, you're going to have the starting of the exams. Obviously, you are you are in two stages of confusion. All of you must be, or two stages of difficulties, or you are taking two tasks. The first thing, or two areas of concern rather. The first thing is about the board exam. Obviously, summative 2 examination is coming up in after a couple of weeks. The second thing about your 11th standard admission. So after 10th, all of you will be seeking admission in different schools over here itself, or some of you may be shifting to India. And as students, you may be having concerns about which group to be chosen, and your parents also may be a little confused about what to be taken. Sometimes already you might have decided about what is to be gone, well and good. So it's always to have my appeal to the parent community is that when you choose this stream for 11th standard, you have to be very, very careful. Just because of the wrong choice, the difficulties may prolong like that for years and years, just because of the wrong choice. So my appeal to you is, choose very carefully, think of what is the aptitude of your children, and what to be chosen. You have to have a clear discussion with your ward and finalize, and then get into it and go ahead with as maximum potential as possible. Remember, there is a general thinking that you have to first priority for going for medicine, then engineering, then things like that. That was actually, in fact, it is in my opinion, it's something like an outdated approach, outdated thinking. Prospects are there in each and every field after you go from higher secondary. Prospects are there. If you are if you are really if you like the content or like the stream, definitely you will be able to excel in it, and there will be a good output at the end of it. It will definitely be a big gain. So the basic thing is whether you like or not. Dear students, you have to see yourself, you have to assess yourself, what is your choice, where you have to get into. So be very careful there. And of course, with your liking, if you get into somewhere or some stream, definitely you will be in a mood to study, you will prepare according to what's the requirement. So at this point of time, it's a very sensitive concern or very sensitive time for you. You have to be very careful in choosing the right stream. So because I've been seeing the children struggling with certain subjects because they don't like the subject. So it's a very crucial time, and it is a very crucial time in the sense you have to have a very right approach in taking up the stream. And because of that, if you have a good choice, definitely you will be happy throughout. That's what exactly required. Enjoy your studies. When you get in 11th and 12th, the days should not be with nightmares. The days should be with studying with enjoyment. right? And that is one side, that is choice of your stream. Second side is about, another aspect which I had mentioned in the previous sessions as well. In April, May, June, these 3 months over here, when you start your 11th standard, you may sometimes find it, take the things in a very lighter note. Because you're thinking that summative 2 examinations, after finishing the summative 2 examinations, I have to take, I have to relax some months, right? So you will be taking in a lighter note. Just because of that, the entire year's work would be in a very big, under a very good question mark, very big question mark. That means just because of relaxing those 2 or 3 months, you will be struggling throughout. You may be struggling throughout. So it will be difficult to recover from that. So my dear students, wherever you get into, whichever stream you are going to, or every stream every subject has got its own difficulties and its own easiness. So you like the subject and get into it and start studying from very beginning. If from the month of April, if you are with the subject, if you are covering up the contents in time, definitely it will be a comfortable year. You will go through in a very, very smoother track, so there won't be any difficulties. So I hope all of you will get your right choice, and all of you will get into 11th standard with lots of positive spirits. I wish you all the very best. With all these blessings from my side, all these wishes from my side, we will move on to today's session. Today we are going to focus some areas of class 10. In fact, class 10 physics, it's only basically 2 major chapters. First chapter already we have discussed in the previous sessions, and second chapter is about like eye and refraction of through a prism, the defects of eyes and things like that. And that also we were halfway through in the last session. All right. So today I will just show you a small video based on the working of eye. After that we will come back to the contents. So you watch the video first.
Structure and working of the human eye. Nature has located the eye close to the brain so that its messages may arrive there quickly. The eyeball is completely surrounded by a layer of soft fatty tissue and placed within a bony orbit where eye is protected. Seen from inside, the protected position of the eyeball within its funnel-shaped eye socket is shown still more clearly. Note that this is a white stalk called optic nerve which connects the eye to the brain, and also these muscles which move the eyeball. This is the empty eye socket within the skull with its bony wall inside and a bony orbit in front. The capsule of the eyeball seems to have 3 layers. This thick, tough outer layer is called the sclera and serves to protect the delicate structure within. This transparent bulging portion is called the cornea. There is also a crystalline lens which is one of the main parts of the human eye. The second layer is called the choroid. It consists of 3 different zones. The first zone is called choroid proper, and it is the part that carries nourishment to the tissues of the eye. Next zone is called the ciliary body. This is the broad ring-shaped band of thin muscle fibers which plays a very active and vital role in the vision adjustment of the eye. The third zone is a well-known iris which expands and contracts the pupil much like the diaphragm of the camera. The innermost layer of the eyeball is the retina, a very delicate membrane. The retina is actually the part of the optic nerve which transmits the light impulses to our brain. The retina is the most important and complex structure in the eyeball. It consists of a complicated arrangement of rods and cones which convert light waves into nerve impulses. Between the lens and the cornea is the aqueous humor, consisting mostly of water and a little salt. This largest space within the eye is filled with vitreous humor, consisting chiefly of water mixed with salt and albumin. It is a highly transparent jelly-like substance and plays a very important role in visual adjustment. The reflected light of the world enters through the crystal transparency of the cornea, pupil, aqueous humor, lens and vitreous humor, which is a clear gel-like substance that fills the middle of the eye and then projects on to the photoreceptors of the retina, which is a photosensitive tissue lying at the back of the eye. The macula is a very small area at the center of the retina that gives us a fine pinpoint center of vision. The area of retina surrounding the macula gives us a peripheral or side vision. The retina converts the light rays into the signals that are sent to the optic nerve and then to the brain. Continual adjustment of the pupil and lens regulates the entry and focusing of light. Every blink helps our eye's natural defense system. The tear film retains moisture and maintains visual acuity. Tear gland secretes the tear fluid, which contains important natural disinfectants to keep bacteria away, and it drains through the tear duct into the nose after flushing and cleaning the entire eye surface, and thus the tear system washes away impurities to maintain eye health.
Yes, welcome back. I hope you have enjoyed the video. This video describes the structure and working of the human eye, and some of the areas you might be well familiar with, might have done in the class properly. And the last sessions we've been talking about this as well, about the similarities and dissimilarities with between the eye and camera. That's one area we had focused last week. Obviously, both camera and human eye got convex lens. But what's the basic difference is, in camera, we adjust the distance between the lens and the screen to get a clear image. That means we are adjusting the image distance in the case of camera. Whereas in the case of eye, we're not able to adjust the image distance. The retina is fixed and the lens also is. So what do we adjust in human eye? We adjust the focal length of the lens itself. This adjustment can be done by the help of ciliary muscles. So what is the name of the property eye has? The name of the property is the power of accommodation. Power of accommodation is the ability of human eye to adjust the focal length of the lens with the help of ciliary muscles. So that is why, when we are aged, we lose the elasticity of the ciliary muscles, thereby we are not able to adjust the focal length up to that extent. So the result of that is we are unable to see the far away objects and we are unable to see the very close objects as well. So what happens is that weakening of the ciliary muscles, that is what is called, what is leading to, what is the defect called? That is called presbyopia. So presbyopia is what is eliminated or can be overcome with the help of a bifocal lens, with converging and diverging lens together, right? So that you can see both the extremes. So in this content, we have therefore the structure, to learn about the structure of the eye. Then we are going to learn about the defects. Clearly three defects you have to learn and their remedies. So what the defect is, what are the reasons for this defect, and how do you remedy it? What are the possible ways to overcome it? Okay, so these are the areas we are studying in this chapter, the first part. In second part, we are talking about dispersion. Okay, so dispersion through a prism we will see. After dispersion leads to, so first of all, refraction through a prism we will see. After refraction, we can talk about dispersion. Dispersion leads to rainbow, right? And rainbow is one of the therefore applications of dispersion, which we have seen already. The moisture in the atmosphere during rainy season, let's say, the water drops act as tiny prisms, and in the tiny prisms, dispersion happen. So during dispersion, in fact, two internal processes are happening during dispersion of white light when it is passing through small tiny drops. Twice they are getting refracted, and once they are getting reflected, total internal reflection happening. So I have seen this. We have seen this one in the last session. And again, one more thing is about scattering of light. That's another area. Scattering of light, refraction through prism, dispersion. These are the areas which we have towards the last phase. Alright, so I'll give you an overall summary of this chapter, and we will do some numerical questions or the board paper based questions. That is, those questions which have been were asked in the board papers that we will discuss after giving you the entire details of what you call as this chapter, eye and refraction. So the second chapter of in 10th standard science, the second chapter of physics we have. Today I'll give you the overall summary, plus we will discuss some questions. Right? So before I get into any questions of that sort, I'll just give you one question as for you to think on and send us the answers. Right? I'll give you a question, read the question carefully, try to figure it out, and get back to us either through the phone or through SMS. Alright, you see the question on the screen. You can watch the question. See the question now. If a person can see the objects only up to a distance from 25 centimeters to 5 meters, what defect is he suffering from? Once again, read the question carefully. If a person can see objects only up to a distance from 25 centimeters to 5 meters, what defect is he suffering from? Right? I hope you read the question carefully. Find out the answers and send your answers to us in this SMS number, or you can call and say, and even if you have any confusions about the contents you are studying, you can bring it to our notice. We will be able to discuss it out as well. Right? So now we will move on to the briefing of this chapter. Okay. So now, yes. So I'll give you an overall picture about the chapter human eye and refraction of light. Okay, so let's see what all the areas we have in this chapter. So we have a look at the screen first. See, we will just have a look at the areas, like these are the main parts of the eye you should learn. Right, iris, you might have seen this diagram, you have to be well familiar with. Okay. Then second, what is power of accommodation? As I mentioned at the beginning, I am giving a briefing about the entire chapter, which is there as the second chapter of physics, and we'll have a brush up through the summary of the chapter. Then we will discuss questions. So have you read the definition of the power of accommodation? Power of accommodation is very much required to see the objects very close to you as well as the objects far from you. Power of accommodation is decreasing as you are aged. Right? See, the normal eye, the focus would be like this. Okay, it's coming through the convex lens. Convex lens is what kind of lens? Convex lens is, it's a converging lens. So the converging lens makes the parallel light rays meet on the retina, so we get the image on the retina. Okay, now you see it's a normal, it's an eye with a defect. See the nearsightedness, which is called myopia otherwise. You see that the parallel light rays not able to meet exactly on the retina, instead it is meeting at a point in front of it. What is the reason for this? Eyeball is large eyeball, or the convex lens is of short focal length. That's the reason. And see how is it remedied. The second diagram you watch, the second diagram shows with the help of a concave lens or diverging lens of appropriate focal length, we are able to rectify the defect of nearsightedness or myopia. Right? And next one is farsightedness. That's again just opposite to what we have discussed in the first part. That is, it shows that the parallel light ray is not able to meet exactly on the retina, instead it is meeting at a point in front of, behind the retina. This happens due to two reasons, two possibilities. First possibility, the eyeball is shorter than or smaller than the normal size one, or the lens can have a longer focal length than the normal. Longer focal length. So it is remedied with the help of convex lens of suitable focal length or converging lens of suitable focal length. Right. So the next point is, I mentioned about presbyopia, defect due to which the nearby and faraway objects may not be seen comfortably and distinctly. This is due to the weakening of ciliary muscles. Power of accommodation of the eye decreases with aging. Right, it is remedied using a bifocal lens. Next, you see the diagram. It's a very important diagram. You should have a very clear picture about what all these angles represent, what all these rays represent. You see, I'll just give you the names. The PQ, that ray is the incident ray, EF is the refracted ray, FS is emergent ray, and you see the angle D is the angle of deviation, then the angle of emergence, angle of refraction, angle of incidence. All these you have to carefully learn. I is the angle of incidence. So angle of incidence, how do you define angle of incidence? It is the angle between the normal and the direction of incident ray. Okay. And the next one is dispersion of white light by a glass prism. Through the glass prism, when white light is passing, can you say why the light ray is getting, the white light is getting dispersed into 7 colors? What's the reason? You should say that white light consists of 7 colors. The 7 colors have got 7 different speeds while passing through a prism. So since they have different speeds, they will split up into 7 colors. Right? So this is the case of dispersion. Right? And you can see in this diagram how we combine the colors back to white. You might be familiar with the concept of Newton's color disk. With all the 7 colors together, we are able to make even white light back. So with the help of 2 prisms arranged in this manner, we would be able to combine colors back to white as well. Right? And see this is rainbow. You know, the phenomenon of formation of rainbow, it's an application of dispersion. During the formation of rainbow, you can see it's a beautiful phenomenon we observe in nature. So all these 7 colors are always, these colors always attract us. This is one of the most beautiful scenes in the nature. So we see this by the dispersion of white light into the component colors through the glass, the water drops, which act as tiny glass prisms. Alright, this is how dispersion really happens. See the sunlight coming through the water drop, twice it is refracted. You can see coming first refraction, then total internal reflection happens, then refraction. So 2 refractions and 1 total internal reflection, that is leading to rainbow. And examples of atmospheric refraction, this we had already mentioned last class about the twinkling of stars as well as delay in sunset and sunrise. That's an example of atmospheric refraction. So I think this is time for a short break, and after the break we will discuss the more of the last part of this chapter, plus we would be able to do some questions based on this. So meantime, you work out the question I had given you at the beginning. That is, a person is able to see the objects at 25 centimeter to 5 meter distance only. Which what is the defect he is suffering from? That was the question. If you know, call us and say. And after the break, we will again see with more questions related to this. This I was just giving a brushing up through the chapter, because already we were quickly going through, because already we had discussed all these the previous sessions. Okay, we will see after the break. Stay tuned.